Welcome back to another CAD/CAM tutorial. In this tutorial, we are going to create the Machinist Jack Assembly using SolidWorks. I have divided this tutorial into 3 parts. In the first part, which is this video, we are going to create the individual components that are needed to create the Machinist Jack. Inside the parts list or bill of material, we have the first part, base. We have the swivel, the bolt, the hex nuts, the screw, and the lock nuts. And they are depicted by these balloons. We can see each of the parts from 1 to 6. And then in the second video, which comes right after this, we create the assembly by adding mates and relationships between the parts to form the Machinist Jack. In a third and final video, we'll create the exploded view, as we can see here. So there are drawings and drafts for every part, as we can see here: the base, swivel, bolt, hex nut, screw, and lock nuts. So there are links to each part of the tutorial in the description. Make sure you check them all out. And I have organized this tutorial also into a playlist that is on my channel. Make sure you check the playlist out, and also check out the playlist for other assemblies in SolidWorks and even in Siemens NX. So this is a very simple tutorial. It may look complex when you just look at it like this. In order to get this whole thing, make sure you follow along and watch the full video and the full tutorial so you know how to create the Machinist Jack. And also like the video, subscribe, and turn on post notifications so you get a notification when the other parts of this tutorial drop, or even when I drop any other tutorial. And make sure you share the video as well to your colleagues and friends so they can also watch it. Without further ado, let's start. The first thing I will do is I'll create a folder in the desktop to store the files that you create. So this will be the Machinist Jack. And then you open SolidWorks. In the SolidWorks window, we create a new file with this new icon. You're creating a parts file, so okay. And this will take you to the SolidWorks 3D modeling workspace. We want to model the first part, which is the base. So this is a drawing for the base. The base can be divided into 3 parts: the bottom block, and then 2 arms. Then you have holes in the arms and then some holes inside the bottom block. So let's first create the bottom rectangular block. So we are adding material, so extruded boss base. We're going to sketch on the right plane. We need this rectangle here, and then we dimension. So a rectangle with the center rectangle method. Now let's dimension. The full length here is 132, and the width of the rectangle should be 14 millimeters. Sketch is fully defined, so exit. And then the distance of extrusion would be 58 millimeters. So you're going to make it symmetric about the mid plane. So set the end condition to mid plane. Okay. We have 2 holes in the block. So we use the hole wizard. We go with the legacy hole so that we can customize the hole anyhow we want. A simple hole for the type, and then the diameter of the hole is 14 millimeters. The depth should cut throughout the whole body. So you come down and set the end condition to through all. There is nothing here we want to touch, so come to positions and then we specify the center for the holes. So click on this face and then we place the first hole here and the second hole here. Now let's add some constraints. So we will make sure that the two centers fall in the same vertical line. So hold down the shift key, click on the two centers. You will see a pop-up here, or you can come here and make the relation vertical. Now let's add dimension. So the distance between the two holes is 100, and the distance from this edge to this center here is 16 millimeters. So the sketch is still underdefined. You have to add the last dimension, which is this dimension here of 29. Now the sketch is fully defined. So okay. So this is the hole that has been created. Then we add fillets of radius 5 to the 4 edges of the block. So the fillet tool, you go with the constant size fillet. And the items to fillet, just make sure you select full preview and then click on this edge. In this pop-up, you can select this so that automatically the system will select the 3 other corners. And then the radius of the fillet, 5 millimeters. Okay. Then we move on to the first arm. Looking at the dimensions on this arm, this is 3, this is 10, this is 32. So 3 plus 10 plus 32, that will be 45. Assuming this is also 10 millimeters like this arm, and this is also 3, that will be 10 plus 3 added to the 45, that will be 58. So that means the two arms have the same dimensions and they are symmetric about the mid plane. So the best thing we can do is just create one arm and then mirror onto the other side. So we create a sketch on this face of the block. First, we need a circle of radius 20, hence a diameter of 40. The distance between the end here and the center of the hole is 54 millimeters. And then you make sure that this center is in the middle of the block. So we connect a line which will be a constructional line from this center to this end point here. You make sure that the line is a vertical line. So click on the line, make vertical. Then we add tangent lines which are also inclined to this circle and connect them to this horizontal line, while making sure that there is a fillet arc here as well. So with the line tool, connect the line from here to this point. Don't let it touch this line, just somewhere here. Go forward and come back, and then we can add a fillet arc here. Now let's dimension. So the fillet has a radius of 5, and the distance from the center of the arc to the other center of this arc is 75. Now we draw just half and then mirror onto the other side. So from the center of the arc to the mid line here will be 75 divided by 2. So from this center to this line here, 75 divided by 2, or when you move your cursor outside, you can see 75 here. The arc has a radius of 5. And then you make sure that this point and then this point here all lie on the same vertical line. So hold down the shift key and click on the 2 points. Make vertical. You can see the sketch has been fully defined. So mirror entities, click on the 2 entities, and then mirror about this center line. Make sure you check the copy mark. Okay. Then we use a horizontal line to join the 2 points on the arc to close out the shape. We also have a hole of diameter 14 here. Now we come to extruded balls base, and then we extrude this area as we can see. Reverse for it to come inside, and looking here we have an offset of 3 millimeters, and the distance of extrusion itself is 10. So from offset of 3 millimeters, reverse for it to go inside, and then the extrusion distance 10 millimeters, merge result, and okay. Then we mirror this arm onto the other side. So click on the mirror face or plane. You come to this arrow, drop it down, and then you are going to use the right plane as the mirror plane. The features to mirror, click on this boss extrude, which is the arm. Okay. Change the color to orange, and that will be it for the base. So you come to this edit appearance, and then you change the color here to orange. You can also change the background to white as well, or just maintain this default background, and then save the parts. You go into the folder that you created. I'll be in a Machinist Jack. This is the first part, the base. Then you create a new file for the next part. The next part is the swivel. So create a sketch on the right plane. Again, we need a circle of radius 22. Hence a diameter of 44. We have a hole as well of diameter 16 millimeters. Then we connect with lines to form this shape. So first have the horizontal line. We make sure that the center of the horizontal line is in the middle of the circle. So hold down the shift key and click on the 2 points. Make vertical. Now the length of the horizontal line is 32 and the distance from the center here is 50. And then we connect the ends to the circle and make sure there is a tangent. So come to extruded balls base and then click on the area that you want to extrude. We make sure the extrusion is symmetric, so come to mid plane, and the distance of extrusion is 32 millimeters. Okay. Then we'll have a drilled hole here. So come to hole wizard, a legacy hole, and the type of hole is a simple drilled hole. Diameter of the hole is 18 millimeters, and then the depth is 38 millimeters. So under the depth, we come to the end condition and set it to blind before we can change it to 38. and you make sure, looking at the cross section of the hole, the 38 is up to the cylinder bottom here and not up to the cone's tip. So we set it to this depth up to shoulder, and then the drill angle is 120 degrees. Come to positions and then click on this face and place the center of the hole in this origin, which will be the center of the square here. Okay. Inside the hole there is a thread of this size, so come to this drop down under the hole wizard. We have this thread here. We select the start location of the thread, that will be on this edge here, and then the end condition, set it to blind, and the depth of the thread is 34 millimeters. Now for the start of the thread, we want an offset upwards so that there will be a perfect thread at the tip or at the start here. So add an offset of, let's say, 2 millimeters, and reverse for it to come to the top. Then since we added the offset, it has pulled the thread upwards, so we want to maintain the thread length. And then since this is a hole, we make sure we set the specification type to metric tap for a hole, and the thread size is 20 by 2 millimeters, which is here. Cut thread and then okay. Now a section view through the swivel, and it shows this cross section, which is very similar to what we have here. So this is the swivel that has been created. Change the color to light gray. So disable this section view here and then come to edit appearance. Change the color to light gray. Save the parts as the second part, the swivel. Rebuild and save the document. And then we create the next part, which will be the bolt. So extrude, because we are adding material on the front plane. This is a hex bolt, so we have a hexagon, which is a polygon with 6 sides. Make this line horizontal. The distance between the two horizontal lines of the hexagon is 25. Exit. The thickness of the bolt head is 10 millimeters. Okay. Then we add the shaft. Again, extruded boss based on this face. And then a circle. The diameter of the shaft is 16 and the length of the shaft is 78 minus the 10 here. That will be 68 millimeters. Check merge result to join with the head. Okay. Then we add a thread on this shaft here. The thread has a length of 20 millimeters and a size of 14 by 2. So come to the thread feature, select this start point. The thread length here is 20 millimeters. And since this is a shaft, the specification type, set it to metric die for shafts. And then the thread size, when you come up here, you can see 14 by 2 millimeters. Again, for a perfect thread at this tip here, we add an offset of 2 millimeters and then reverse for it to come outside and maintain the thread length, just like we did for the swivel. cut thread, and then OK. We want to draft this face of the hexagon, so come to extruded cut, click on this face, and you have a circle that is tangent to the size of the hexagon. So hold down the shift key, click on the circle and the side of the hexagon, make tangent, exit, and then you make sure the length of cut will be the same as the length of the head, so 10 millimeters. We want to flip the side to cut, so we cut the other side instead of the area inside the circle, and you add a draft, and the draft angle is 45 degrees. Okay, so this is how to create a bolt in SolidWorks. Then we change the color to powder gray, which is a lighter color or a lighter version of gray. So come to this edit appearance, and then change the color to this lighter gray color here, and save the parts. This will be the third part, the bolt. We move on to the next part, which will be the hex nut. And we use a similar way as we used for the bolt to model the hex nut. So extruded boss base on the front plane. We have a hexagon, 6 number of sides. Make this a horizontal line, and the distance between the two horizontal lines here as 25 millimeters. We have the hole of diameter 14 here. Exit. And then the distance here is 10 millimeters. Okay. We're going to pass a thread through it. The thread has a size of 16 by 2 through the full length. So this will be the start point. We add an offset of 2, reverse for it to come outside, and then the end, since the full length of the nut is 10 millimeters, let's say the full length, we make it greater than 10, which would be reasonable, so 15. So the thread, as you can see, passes through the full length of the nut. So since this is a hole that we are creating a thread in, we use a metric tap and a thread size of 16 by 2 millimeters. Cut thread, make sure you select this method and OK. Finally, we add a draft to one edge. That will be the outer edge here, in a similar way as we did for the bolt. Extruded cut, and then you create a circle that is tangent to the size of the hexagon. Flip side to cut, and then you have a draft of 45 degrees for the draft angle. Okay. Change the color to powder gray, which will be a lighter version of gray, and then save the parts. This is the fourth part, the hex nut. Move on to the next part, the screw. So the screw is a shaft, so extruded boss base on the front plane, have a circle, and the diameter of the circle is 20 millimeters. And the length of the shaft is 56 millimeters. We We have a hole here of diameter 10 and a distance of 16 from this edge. So extruded cut, we are going to cut on the top plane. A circle of diameter 10 millimeters, and the distance from the center to this edge is 16 millimeters. Make sure the circle is in the center, so hold the shift key, click on the center and the origin here, which will be the center of the shaft. Make vertical, exit, and then set the end condition to through or both, to pass through both sides of the shaft. Okay. We have a chamfer of dimension 2 millimeters here. So chamfer, we need a distance chamfer and a symmetric chamfer of 2 millimeters, and then click on this edge. Okay. We have a thread here as well. Start point of the thread here. The length of the thread is 32. Size of the thread is 18 by 2. So again, for a perfect thread, we add an offset of 2 and then maintain the thread length. Since this is a shaft, we use the metric die. The thread size of 18 by 2. Cut thread and OK. The color is light gray, so change the color. And save the part. This is the fifth part, the screw. Then we move on to the final part, which is the lock nut. So extrude boss base, again on the front plane. We have two circles of diameters 45 and 18. Exit, and then the length is 8 millimeters. Okay. There's also a thread through the lock nut of size 20 by 2. This start point, an offset of 2 millimeters coming outside. And then since the full distance is 8, we just add a length of, let's say, 11, which would be reasonable for the thread to pass through the full length of the lock nut. Since this is a hole, use the metric tap. A thread size of 20 by 2 millimeters. Cut thread and OK. Then we change the color to light gray. And then save the part. This is the sixth and the final part, the lock nut. So yeah, that is the end of this part of the tutorial. So you have modeled all the components that we need. to create the Machinist Jack. In the next video, which will come right after this, we'll create the final assembly. So I'll see you in the next one.